Hello and welcome you all to this particular section 4, which is subnetting different classes. Now in this particular video we are going to study about subnetting class C. Now subnetting class C I have divided into two videos because this is a very lengthy lecture. Before starting with subnetting, let us have a quick review of section 3. In section 3 we studied about IPv4 classes, class A through class E. We know that class E is reserved and class D is for multicast. Class A default subnet mask we know, class B default subnet mask, class C default subnet mask, and then these are the default prefix lengths for those classes. For class A the first octet range is 1 through 126, for class B 128 through 191, for class C first octet range is 192 through 223, class D 224 through 239, and class E 240 through 255. This is a reserved class or a special class, special purpose class, and class D is for multicast. When calculating number of valid hosts per subnet, we subtract 2 because one of them, the first one is the network address and the last one is the broadcast address. Okay, now we need to know about the magic numbers. So when we have one bit in the first place and all zeros, then its equivalent is 128. I think we have done this calculation. When 2 bits are on and the remaining 6 bits are off, then its decimal value is 192. Likewise with 3 bits on, 224, then 4 bits on, 240, 5 bits on, 248, 6 bits on, 252, 7 bits on, 254, and all bits on 255. These are called as the magic numbers, and we are going to use these magic numbers in our subnetting calculation extensively. So please make sure that you know these numbers very well. And for mastering the subnetting chapters, all that you need to do is you have to write them again and again. So make sure that your notebook and pen is ready with you and you do these calculations a lot many times as possible until it fits into the head. Okay, what do we learn in this section? So in this section we are going to study about subnetting of class C. Now we are going to see how we subnet. For subnetting we need to borrow the host bits. So when we borrow the host bits, what happens? We increase the number of networks and decrease the number of hosts. So host network bits are increased, as a result number of networks is also increased. Host bits are decreased, as a result host bits number of hosts is also decreased. For studying subnetting we need to learn this formulae for those calculations. Number of networks, the formula is 2 to the power bits borrowed. If I borrow 1 bit, then it will be 2 power 1, which is 2. If I borrow 2 bits, then it will be 2 power 2 equal to 4, and so on and so forth. Number of hosts per subnet, the formula is 2 power host bits minus 2. I think we have already seen this formula, correct? So if I borrow 1 bit, then what happens? Number of host bit decreases by 1, whereas number of network bits increases by 1. So whatever increases over here, same decreases over here. Then we need to know about the magic number. Earlier we already saw the magic number, if you remember, this one. So we are going to make use of this particular number. When 3 bits are borrowed, then the magic number is 111 and remaining 5 bits 0. So this is the new octet after borrowing 3 bits. Now this magic number is 224. That is what this particular table gives. I just explained over here once again. We need to know the block size. So block size formula is 256 minus whatever magic number we have got. So in this case it is 256 minus 224, just as an example, which is 32. So when I say 32 is the block size, then what happens to my first network's interesting octet? I just add this value to get my second subnet or the next subnet. Just understand these things, and as we go further, after doing all those subnetting things, all these things will be clear to you. At present it may be confusing, but trust me, this will be very easy and you cannot forget them. And then we need to know the new subnet mask. So the new subnet mask would be whatever, for example, my old subnet mask was 255.255.255.0. So fourth octet is the interesting octet. Now whatever is the magic number, that is replaced by the 0 in the interesting octet. That is how we get the new subnet mask. Let us now start with borrowing bits and doing these calculations. Further, you will see that when I am doing these calculations, I am using these 5 values all the time. Okay, suppose in case 1 I borrowed 1 bit. So if I borrow 1 bit, what happens to the number of networks? We know the formula. Number of networks is equal to 2 power 1 because 1 bit has been borrowed, and 2 power 1 is 2. So whenever you borrow 1 bit, you get 2 networks. If you remember, in the default there is only one subnet, because in the default no bits have been borrowed. So it would be 2 power 0. 2 power 0 is 1. That is why the default subnet has got only one subnet or one network. Number of hosts per subnet. This I am talking about class C. So in class C, the last 8 bits are for the hosts. Now 1 has been borrowed for networking. So 7 are left for the hosts. So it is 2 power 7 means 128 minus 2 is 126. Now we know why this 2 is subtracted, because first is the network address, last is the broadcast address, and these two addresses cannot be assigned to a host. Magic number. Because I borrowed 1 bit, so this is 1 followed by 7 zeros. Now this is the binary. Now this binary is equal to 128 decimal. Now I have given you a hint over here. Now this particular magic number helps to find the block size, and it gives the new subnet mask as well. So let us see what is the block size. Block size is 256 minus magic number. That is what I have written over here. The magic number helps us to find the block size. So block size is equal to 256 minus magic number. 256 minus 128. This is equal to 128. Now this particular value will give us the next subnet. Now in this case magic number is 128, block size is also 128. So don't get confused. The next subnet is given by the block size, and the new subnet mask is given by the magic number. Make these things very clear. Block size gives the next subnet, magic number gives the new subnet mask. So subnet is the network, subnet mask is the value corresponding to the network. Okay, I just written here property. Because we borrowed 1 bit, there were 2 networks. So these are my 2 networks, first network, second network. Now I am taking the example of private class C IPv4 address, which is 192.168.0.0. So this is my network. Now this network is broken into 2 networks. So this is the first network. This is the first network. What would be the second network? So for that purpose, I have to go back and see the block size. So block size is 128. So here clearly it is mentioned, this gives us the next subnet. So this fourth octet is the interesting octet. So this fourth octet 0 will be replaced by 128, which we got from the block size. Remember. So these are the 2 networks. Now I need to find the broadcast address of my first network, and there is a formula. Broadcast address of the first network is always 1 less than the second network. So 192.168.0.127, and if you go back, the block size is 128. So if I add 128 to this, I will get the third network. 128 plus 128 is 256, but 256 has no place in octet because minimum is 0, maximum is 255. So that network does not exist. But that value is 256. So 256 minus 1 is 255. Alternatively, you can always remember that the last network will always have the broadcast as 255. So my broadcast for the second subnet would be 192.168.0.255. So these are my two subnets. How did I get these two subnets? By borrowing one bit. So we can say that if we borrow one bit from the host portion, we always get two networks. Now earlier, when nothing was borrowed, there was one single network, and that single network had 254 hosts. Now what is going to happen is these 126 are the valid hosts in the first network, and another 126 are the valid hosts in the second subnet or the second network. So originally there were 254, now 126 plus 126, 252. So as we do subnetting, number of networks increases and the number of valid hosts decreases. The total valid host also decreases and per subnet also decreases. This is very simple example. If you have any confusion, go through this video again. Let me take you back again. So I borrow one bit, and according to this formula I get two subnets. I find the number of hosts per subnet, which is 126. Let me match. This is 126. Magic number is 128. How I get this magic number? By looking at how many bits have been borrowed. So this is the binary of the magic number, and we need to find the decimal. Then we need to find the block size to find what is our second subnet. So block size formula is 256 minus the magic number. So block size we get from magic number, and magic number we get from this information, how many bits have been borrowed. Likewise, we need to find the new subnet mask, which we get again from the magic number. So this network and this network, they both will have a subnet mask of 255.255.255.128. So I have first network 192.168.0.0 with a subnet mask of 255.255.255.128, and I have another subnet 192.168.0.128 with the same subnet mask of 255.255.255.128, or this is /25, this is also /25. These things will get more clear as we borrow more number of bits. Let us see next example. Case 2, borrow 2 bits. So if I borrow 2 bits, how many networks are there? 2 power 2, 4. Now how many hosts will be there per subnet? Total 8 bits were there originally for the host portion. Now 2 have been borrowed by network. So 8 minus 2 is 6. 2 power 6 is 64. So now we have 62 hosts per subnet. So there are 4 subnets. Each subnet will have 62 hosts. Let us find the magic number. How do we get the magic number? By knowing how many bits have been borrowed. 2 bits have been borrowed, so 1 1, and remaining 6 bits would be 0. Now we already know how to calculate this value. This is 192. So our magic number in terms of decimal is 192. Now let us find out the block size. The formula is 256 minus the magic number. So 256 minus 192 is 64. Now this value gives us the next subnet. So my first subnet is 192.168.0.0. So second will be 192.168.0.64. Let us see. So first subnet, second subnet. So we get this value from the block size. Now to get the third subnet, again add 64 to this value. So 0 plus 64 is 64, which gives the second subnet. Again 64 plus 64, the same block size we keep on adding, and we get the third subnet. Again 128 plus 64, which is 192. So we get the fourth subnet. That's it. See here it says totally there are 4 networks. If I add 64 to this, what will happen? This value will become 256, and we know that in 8-bit binary system the maximum is 255. But you can say that last 256 minus 1 is 255, which gives me the broadcast address for this fourth subnet. So this 192 minus 1 will be 191, and that will give me the broadcast for the third subnet. Likewise 128 minus 1, which is 127, that will give me the broadcast for the second subnet. Similarly 64 minus 1, 63. So this is my broadcast address for the first subnet. So 0.0 is the network address, 0.63 is the broadcast address. Likewise 64, 127 are the network and broadcast addresses respectively, and these also correspond the respective network addresses and broadcast addresses. So one more than the network address will be the first valid host, and one less than the broadcast will be the last valid host. So from 1 through 62 totally there are 62 hosts. From 65 through 126 is also 62 hosts. These are 62 hosts. These are also 62 hosts. You can calculate manually. Let us verify it. 64 minus 2, 62 hosts per subnet. There are 4 subnets. So these are the 4 subnets, 1, 2, 3, 4, and these are the 62 hosts per subnet. So this is verified, this is verified. We used the magic number to find the block size, and we got the second subnet, third subnet, fourth subnet. Now we again use the magic number to find the new subnet mask. So the last, what is the default subnet mask of this class C? 255.255.255.0. So this 0 is replaced by this magic number, and we get the new subnet mask. So what happens over here? Each of these subnet will have a subnet mask of this 255.255.255.192 or /26, because 2 bits have been borrowed. For class C, /24 is the default prefix length, because we borrowed 2 more bits, so it will be /26. So when you write, you say that this network is 192.168.0.0/26 or 192.168.0.0 space 255.255.255.192. Same is over here. So this network is 192.168.0.64/26 or 192.168.0.64 space 255.255.255.192, and same thing over here. Hope the things are clear. You have to write them again and again, otherwise it does not get into the head. Let us see next example, borrowing 3 bits. So when I borrow 3 bits, the number of networks, the formula is 2 to the power number of bits borrowed. So 2 power 3 is 8. See what is happening. I borrow 1 bit, there will be 2 networks. I borrow 2 bits, there will be 4 networks. I borrow 3 bits, there will be 8 networks. So number of networks is increasing as we borrow more number of bits. and this borrowing will be contiguous. So out of 8, 3 have been borrowed for network. So 8 minus 3, 5. 5 are left for the hosts. So 2 power 5 is 32. 32 minus 2 is 30. Again we know why we subtract these two. One goes for the network, another goes for the broadcast, and these two addresses cannot be assigned to a host. Because 3 bits have been borrowed, so the magic number will be 111000000 in binary, and when we convert this binary it becomes 224 decimal. Remember, this magic number helps us to find out the block size, and it also gives us the new subnet mask. So from this number of bits borrowed we can find the hosts per subnet, because if something is borrowed from hosts, then host has less number of bits. Again, from this borrowed bits we can find the magic number. So this borrowed bits gives us number of networks. It also gives us number of hosts, and again it gives us the magic number in binary and the magic number in decimal. Now let us find out the block size, because after finding the block size we get the second subnet. There is a formula for a block size, 256 minus the magic number. So 256 minus 224 is 32. So what will happen? My first network is the default one, 192.168.0.0. So because the block size is 32, so my second subnet or the second network will be 192.168.0.32. How do I find the third subnet? Add the same block size. So 32 plus 32 is 64. How do I get the fourth subnet? Again add the same block size to this 64. So 64 plus 32 is 96. 96 plus 32 is 128. 128 plus 32 is 160. 160 plus 32 is 192. 192 plus 32 is 224. If I add 32 over here, it becomes 256. So one less than that is 255. So this is my broadcast for the 8th network. So 8th network address minus 1 will be my 7th broadcast. So like this, 191, 159, 127, 95, 63, 31. Now remember that these 8 addresses, which are the network addresses, and these 8 addresses, which are the broadcast addresses, they cannot be assigned to a host. That is the rule. Now from 1 through 30, how many are there? 30 hosts. So here also, these are also 30 hosts. These are 30 hosts. Let us verify. Yes, 30 hosts. 8 networks. Yes, 1, 2, 3, 4, 5, 6, 7, 8. So first two things have been verified. Now this magic number we get from here. So we use this magic number to find the block size. We already got from this block size, we already got this 8 subnets. And now let us see the new subnet mask. So new subnet mask means replace the interesting octet 0 by this magic number. So this will be the new subnet mask of each of these 8 subnets. If this was not subnet, then it would be 192.168.0.0/24. But now this is 192.168.0.0/27, because 24 plus 3. So either you say in terms of CIDR notation, which is now /27, or you can say 255.255.255.224. They both mean the same thing. Unless you write it, you won't understand. Okay, let me see one more example. 4 bits borrowed. So 2 power 4, 16. 8 minus 4 is 4. So host is left with 4 bits. So 2 power 4, 16 minus 2 is 14. This is the magic number. 1, 2, 3, 4 ones are there because 4 bits have been borrowed. This comes to be 240. Now block size is 256 minus magic number, which is 16. So before I check with this, 16. So what is my first network? 192.168.0.0. So what would be the second network? Add 16 to the last octet, 192.168.0.16. Now this is the block size. Keep on adding 16. So 192.168.0.0, 0.16, 16 plus 16 is 32, 32 plus 16 is 48, 64, 80. So we get totally 16 networks. Let us verify. Yes, there are 16 networks with a block size of 16. So when we borrow 3 bits, we got 8 subnets with a block size of 32. Now when we borrow 4 bits, we get 16 subnets with a block size of 16. Now this 16 minus 1 is 15. Now this becomes the broadcast address. So there are 16 subnet addresses and there are 16 broadcast addresses. So 16 plus 16, 32. These 32 addresses cannot be assigned to a host. So what is happening, as we increase the number of networks or as we increase the borrowed bits, the overall IPv addresses are wasted. But this is useful for different departments. Maybe in your organization there are 50 different departments, so we need to have at least 50 different subnets. So the first valid host is 0.1, and in this case last valid host is 0.14, one less than the broadcast, and this is one more than the network address. So totally 14. These are also 14. Let us verify. Yes, 14. So we already used this magic number and got the block size. Now let us see the new subnet mask. So this new subnet mask is 255.255.255.240, or it is same as /28, because 24 are already there by default and these 4 have been added. 24 plus 4 is 28, so /28. So each of these 16 networks will have a subnet mask of 255.255.255.240 or simply /28. I think we will stop over here, take a break, and then we will look in the next video. Thank you. Please spend some more time with these calculations before going into the next video. Thank you for watching this video. See you in the next. Until then, bye.